First of all, I would like to thank the organizers, Sasa, Thomas, Wansan, everyone involved in the organization of this amazing school. And thank you for inviting me to talk about containers today. So I'm Alexander Moreno Briceño. I'm at the physics department at Antonio Nariño University in Colombia. And my field of work is high energy physics, particle physics, and I'm also one of the conveners of the training group at the High Energy Physics Software Foundation, the HSF, and also Julia for High Energy Physics. As I said before, we're going to talk in this morning session about containers. And before that, I would like to ask you a couple of questions. Please raise your hand if you are familiar with containers in general. What a container is in general, in our real life. Okay, good. Are you familiar with containers in software and computing? Okay, good. Do you know what a Dockerfile is? Oh, that's good. Have you written a Dockerfile before? Okay, it's reducing the numbers. That's good. Do you know what a container image is? Okay, we have experts then here. Have you built and run a container? Have you run code inside a container? Okay, so since you are already experts on this, please bear with me because we're going to cover the basics today. So we're going to scratch the surface. As you probably know, people who have already done many of those things, there are many, many amazing things that you can do with this technology. So again, we're going to scratch the surface here. So far we have been working with different tools, technologies, platforms that allow us to improve the way how we develop scientific software. We have been using Pixie as a package manager. We have been using Git as a control version system, GitHub for collaborations. Probably most of you know and have worked with GitLab as well. We have used PyTest for testing, CI/CD, profiling. We have even used AI yesterday to improve the way how we develop our codes. And then we are in a position where we can ask ourselves, or we would like to do, is to share our code, our application in this case, the case for the pCoffee project. We want to share our results and our analysis with other people so they are able to reproduce what we're doing or improve what we're doing, confirm our results. And that's where we think about containers. So the goal of this session is to introduce containers for creating, maintaining reproducible software environments to ensure reproducible research results. And in this particular case, we're going to use Docker and Podman. We're going to run Docker and Podman locally, but you can run them also in the cloud or on HPC systems. But for those cases, Apptainer is a better option. Might be a better option, but Docker and Podman could be used as well. So at the end of the day, you're going to have the elements. If you're not familiar with containers, you're going to have the elements to create a pCoffee container. So basically, at the end, what you're going to do is you're going to write a pCoffee Dockerfile. That's a text file where you have all the information about the image that you're going to build. And you're going to run the container from that image. I'm going to explain in a moment what those things are. And inside that container, you're going to be able to run the analysis, to generate the plot, and then to visualize that plot in a browser. And just let me show you briefly here what it is. So I already have the Dockerfile. I'm not going to build the image. I already did that. I'm going to show you in a moment those steps, step by step. Again, people who already know how to do that, please bear with me. I know you already know that, but we're going to cover the basics here. So I'm going to run the, I already have the image. I have the Dockerfile. I build the image. I can run the container. So I'm going to do this. Just want to show you Docker run. I'm going to explain all these commands in a moment. And the name of the container, which is, for some reason, OK. The worst nightmare. It's not running. So I'm going to have to build the image. Didn't want to do that, but apparently I removed that yesterday. And it's called the coffee project. OK. This is funny. Docker is there, but it's not working. This is really funny. It's here, should be working. Let me see. OK, so finally. Sorry, that happens. It worked yesterday perfectly. Well, OK. So again, I already had the image. That's what I was looking at here. This is the list of images that I have with Docker. I'm again show those commands in a moment. But this is the container that I run from that image that I built from the pcoffee Dockerfile. And then, as you see, I'm in the pcoffee environment, and I'm already inside the container. And then inside the container, I'm going to run the analysis. And this is what you should get. So we go to the data file, which is in the analysis directory, and the coffee productivity .csv, and the output. I don't know why it's this. It's the analysis. This is no, call it fitted models .toml, and I want to see the rankings. So I'm already again in the container, and as you can see here, I have the model rankings here of with the R-square score. And now I would like to see the nice plot that we got the first day. Then we go to pick coffee, plot data, file, and this is an analysis coffee productivity.csv, and then you have models here, again analysis fitted models, and I'm gonna put this in the same place. I'll put analysis, I'm gonna call it productivity plot .png. Sorry?
Productivity. Singularity.
Yeah.
Yeah.
Okay. So I run this, and then I can see that plot here. So I can copy this link, and then I can come here. I changed a lot, and then yeah, okay. So I have here all the directories that I have or the files in this directory, and I want to see the plot, and this is the plot, the nice plot for the Picky Coffee project. And I run everything inside the container. So as you saw, I didn't care about the code, right? I mean, all that you did during the last few days, I didn't see anything like that, but I was able to reproduce the results here. And this is, well, at the end of the day, that you would like to do with a container. Now, of course, if you have some experience already with containers, the Dockerfile is going to be maybe easy for you to do. If not, it's going to take some time to do it. So just be patient and keep it simple. Okay, so we're going to start talking about containers. And first of all, I'm going to introduce containers, what they are, why they're important, or they are useful for us. And then we're going to start using some command lines with Docker and Podman. They are basically the same. I'm going to explain why. Then how to remove containers and images, and how to find containers, in particular on Docker Hub. And then probably the most interesting part is what if I want to create my own image, and from that image run a container. So we have to create Dockerfiles, which is a text file. I'm going to give you some tips to write down those files. And at the end, we're going to introduce some basic ideas about Apptainer, sorry. And again, we're going to run everything locally. So if you have installed Podman, Docker, Apptainer, you will be able to run many of these commands. And again, I will remind you about the activity, which is to create or write the Dockerfile, build the image from the Dockerfile, and then run a container from that image. Okay, so in this section, we're going to see what are containers, why are they important, and what is Docker, Podman, and Apptainer. So you have probably faced these challenges when you develop your scientific software, in particular when we think about reproducibility. Probably you have faced these challenges, or you will at some point in your life. And it's, for instance, the difficulty to install software tools due to multiple dependencies. For instance, you want to install software, but then before that you have to install a bunch of other libraries, dependencies. That's sometimes complicated. Sometimes you find that the software that you want to use is not available for some operating systems. So maybe it works on Windows for some reason, but it doesn't work on Linux, or vice versa. If you work in a collaboration, you get different results due to the fact that every one of you are using different software versions or even different operating systems. If you use Mac OS, I'm using Linux. This one is very popular. You develop a software that only works on your computer, right? And when you try to install that software on someone else's computer, it doesn't work anymore. So it works on my computer. So yesterday night, the Picky Coffee container was working on my computer, but it didn't work today. So sometimes it's really hard to install a software package on other computers or other operating systems. Oh, by the way, I'm a Linux user, so Mac OS is really nice, but I don't know how to install a package there. Sorry for that. But Windows, I use Windows, but the last time I think it was like 20 years ago. So I'm that old, sorry. But sometimes it's hard to install some packages on other computer or operating systems. And of course, these challenges come with negative effects, very negative effects. Then we cannot replicate software environments. Again, it works on your computer, but it doesn't work on mine. So I cannot replicate those software environments. I cannot use tools because they are not available or they are hard to install. I'm going to avoid mentioning cases because this is being recorded. Somebody can see that. But I've seen cases of software that is really, there's a very popular package. I'm not going to say the name. I tried to install that many, many times. It was really hard to do that. I couldn't. I think they realized that it was, I wasn't the only one. The developers of that package, they realized that it was really, really complex to install. And they have been improving a lot. Now it's easier. But a couple of years ago, I wanted to use it, but it was so hard that I gave up. I just gave up. And I said, okay, maybe next time. And that's not good, right? We cannot build upon work because the system configuration cannot be reproduced. And at the end of the day, we cannot reproduce results. And well, we have been talking about reproducibility, right? And sustainability of scientific software. So it is important to reproduce results, like the one with the P-Coffee container. I reproduce the results and the plot of the software package that we have been developing during these days. And with these negative effects, this is where containers come to the rescue. And containers help us to package software, dependencies, and resources into a consistent, reproducible, and portable environment. They're very light, and I'm going to show you in a moment that. So, as I asked you at the beginning, I think one of the really nice things about containers is that we already know what a container is, right? My son is 4.5 years old. He has a little box, and inside that box he has the parts of a truck. And he called that box a container. I didn't tell him. He said, this looks like a container, okay? And if he wants to play in the living room, if he wants to play in the bedroom, he takes his container, he asks for his container, and then he takes it, he opens the container, takes all the parts of the truck, builds the truck, plays around, and when he's bored, just put everything inside the box and save it. And if he wants to play again, he takes the box, the container, and he takes it anywhere, and he plays with that. And that's basically the idea of a container in software and computing. Of course, with a lot of many details, but that's the basic idea, right? Actually, the Cambridge Dictionary defines a container as a very large metal box used for transporting goods. And that's the idea that we have about the container. And those goods are transported by rail, sea, air, and/or roads. And as you can see, here there is only one container, and here there are many, many, many containers. Today we're going to talk only about one container, and we're going to run only one container. You can run multiple containers, and we're not going to talk about that today because of time constraints. I mean, again, we're going to scratch the surface, and there are many amazing things with this technology that you can use and learn. Okay, so a container, the formal definition of a container is a standard unit of software that packages up code and all its dependencies so the application runs quickly and reliably from one computer environment to another. So basically, you can run that container on any operating system. And this is basically how it works. And if you use Linux, good for you, because containers are a Linux thing. So it runs natively on Linux. But if you have Mac OS or Windows, and if you went through the installation, you notice that you had to go through a very long process, longer than Linux. The reason is that Docker, Podman, Apptainer run, again, on Linux, and on Mac OS and Windows, you have to install a virtual machine. For instance, in Windows, you have to install, well, you can use WSL, which is basically a virtual machine which emulates the Linux kernel. And then you can run Docker, Podman, Apptainer on top of that. And then you can run different applications on Docker or Podman or Apptainer. What are the differences with virtual machines? Probably you're familiar also with virtual machines or you have used virtual machines. And let's say that the main difference is that virtual machines are heavier, are less flexible than containers. I'm going to show you containers are very light, maybe below 1 gigabyte or something like that. But virtual machines can be, I don't know, 30, 40 gigabytes. And basically, with a virtual machine, you are installing an operating system on another operating system. So I remember 20 years ago when I decided to move from Windows to Linux, at some point, because everybody was sending me Word documents and Excel files and things like that, I wasn't able to see that on Linux at that time. And I wanted to install a virtual machine, Linux on Windows. And it was a real pain. Heavy, it's not flexible. Containers are easy to, as I said before, they're portable, they're very light, they're flexible. Actually, you can, whatever you want to install in your image, or whatever you want to have in your container, you can install it easily. There are some platforms to run and deploy containers. Probably the most famous one is Docker, which is again a platform for developing, shipping, and running applications in containers. Docker has a public registry in which you can share and collaborate on container images, which is Docker Hub. You can pull images from Docker Hub and push images to Docker Hub. We're going to see that in a moment. Docker has a very similar syntax to Git and Linux, so if you already know that, well, it's easy. It's going to be easy for you. And this is basically what we have, and we have said before. We have Dockerfiles, which are text files in which we basically put all these steps to build the image. And the container image is an executable that bundles together all the components for an application or environment. And from that container image, we run containers, which are runtime instances of images. And we can have many containers from the same container image. Podman is another option. It's an open source alternative to Docker, and it has some advantages over Docker. For instance, Podman is able to run containers as a non-root user, and that's a big advantage over Docker. And the reason is that Docker has a daemon which runs as a super user to run containers. And that comes with a security issue, because that daemon is basically play around on your laptop with root privileges. So, I mean, my laptop, well, that's fine, there's nothing there, there's no problem. But if you work on, I don't know, server cluster, that might be a real problem. Docker Desktop has some licensing restrictions, and maybe in some institutions you cannot use it because of that. And basically, Podman is a drop-in replacement for Docker. So basically, you can use the same commands and workflows that you use with Docker. And the reason is that Docker and Podman are part of the Open Container Innovation. Yeah, OCI, yeah, Open Container Innovation. And they promote these standards for building images and running containers. So as I'm going to show you in a moment, the only thing that you have to do is to change Docker for Podman in the command line, and that's it. The commands are exactly the same. Apptainer is, well, formerly known as Singularity, is another containerization technology. I'm going to talk about that later today. And they're used widely in high-performance computing. And in some areas, for instance, in high-energy physics, is getting a lot of attention, well, HPC and HTC systems. What are the advantages then of containers? If you remember all these challenges and negative effects that I mentioned at the beginning. With containers, for the development and deployment of scientific software, we assure the reproducibility of the work that we are doing. Portability, as I mentioned before, they're very, very light. The scalability, we can, as I'm going to show you, build from different Docker images. We can configure our images as we want to. It helps for the documentation because it tells us about how software package is improving. It helps also with the preservation of the work that we are doing and the distribution as well. So there are many advantages for using Podman and containers in our workflow. So we're going to start running some command lines. So if you're, again, familiar with this, again, please bear with me. If not, you can follow these lines and see how it goes. So, okay, left, right. So on your left, you see the Docker commands. On the right, the Podman commands. And you're gonna see, you see they are the same. The difference is that on the left, I use Docker. On the right, I use Podman. Again, for instance, to list the images, they are basically the same commands. They are the same commands. The difference is on Docker, I use Docker. If I have Docker installed, I use Docker. If I have Podman, I use Podman. So, can you see? Yes. Okay. So the basic ones, Docker version. So I can see the version of the Docker that I have installed. Probably you have a different one. Again, I'm a Linux user. This is probably a little bit old, so if you see any difference, it should run the same without any kind of problem. The same one with Podman, and I have the version that I'm using here. Or we can have different other information, a little bit more about the client, the server, if I see some Docker version, and Docker info gives me a little bit more information. And I want to show you something. Oh, maybe I should do this. That's okay. And you can see this. Docker and Podman, of course, they are different entities, but Docker saves all the images on this location, on this directory. And to have access to that directory, you need root privileges. And Docker does that automatically. As I said before, Docker plays around with your system. It has access to the system or your system on your laptop as a root. Again, that's a security problem, but well, that's how it works. But Podman is different in the sense that if you see here, well, there's a lot of information here, but it's this, not here. It saves the images in your home. So it doesn't, it doesn't need privileges to save the images on your system. Okay, so we can see the list of images if we use, again, Docker or Podman, and there are many. Well, it's quite useful to check the help. And you see all the list of commands that you have here, the common commands, the management commands. And for instance, you have here run to create a new and run a new container from an image, execute to execute the command in a running container, ps to list containers, build to build an image from a Dockerfile, pull to download an image from a registry. In this case, we're going to do this from Docker Hub, push to upload an image to the registry. In that case, for instance, for Docker Hub, you need an account there to do that. Images to list the images. I'm going to look for that one. So if I run Docker images, dash help, then you see what it does, list all images. And these are all the possible options to list the images. So you can run Docker image ls, Docker image list, or Docker images, and you're going to get the same result. So Docker images, I have a bunch of images here, but if you probably if you haven't done this before, you're not going to see anything because you haven't pulled any image. So you see there is the information that you can see here, the name of the repository, a tag, which I'm gonna show you later, but the tag is basically the version that you have, that repo, the image ID, when it was created, and the size of that image. So as you can see, many of these images are very, very light. We're talking about megabytes. And the big one is actually that one that I run today, the container of the Big Coffee project, which is 1.5 gigabytes. It's a huge one. And I try to keep it simple. Maybe that's the reason. There are some good practices to write a Dockerfile to reduce the size of the image, because you don't want to have a big image here. So there are ways to improve that. I'm going to talk about that later. So again, for Podman, I can do the same, Podman images. And Podman images, as you can see, I have a bunch of images there with the same information, the name of the repo, the tag, which is the version, the image ID. This is very useful, when it was created, and the size of the image. And as you can see, well, I have less here in Podman than in Docker. And well, the reason, again, they are different entities, so they save those images in different places. As I said before, the Docker saves those images as a root, and Podman doesn't need those privileges, so they save those images in different places. That's what I have more in Docker than in Podman. I can, for instance, if you have a lot of images on this list, you can, for instance, you're interested in looking at what images are related to Python. So I just do Docker images Python, then I see all the Python repos that I have here with the tag, versions that I have, Python 3.10, 3.9, 3.7, even 2.7. I don't know why, but I have that one there. The image ID, when it was created, and the size. And again, these are very light images, the order of megabytes, which is really, really good. Or I can do something a little bit more complicated, but I can filter that search using Python, and I get the same results, but I think the first one is yes, sure. Too much? Let me see, because I lost my.
I prefer to remind you that there is a good doc on how to write neat tiny images that for the paper, please open the Google Doc if you can.
Is it better? Thanks. Okay, and again, you can use the same for, instead of Docker, use Podman, and you're going to see, of course, the Python versions that you have as well. Now we're going to pull an image. So we're going to run docker pull and the name of an image. In this case, I'm going to call it, I'm going to pull hello world. And if you run this for the first time, it's going to pull the image from Docker Hub. It's going to give you some information. I already did that. So the image is up to date, so I don't have to do anything else. And then from that, I think, yeah, yeah, let me see. I can run that image. So I can do docker run and the name of that image, which hello world, and then this is what I get. Some containers just run like this one and give you a result. The result of this one is the hello from, is this text, hello from Docker. This message shows that your installation appears to be working correctly, and blah, 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 blah. And it explains what it does. To generate this message, Docker took the following steps. The Docker client contacted the Docker daemon. The Docker daemon pulled the hello world from the image from the Docker hub. The Docker daemon is the guy that plays around with your computer as a root. Okay, so could be a good friend, but and then the daemon created a new container from that image, which runs the executable that produces the output you are currently reading. And it says try something more ambitious, and you can run an Ubuntu container with Docker run it Ubuntu bash. So we're gonna run this one. I'm gonna. You can do the same with Podman again. So if you have Podman instead of Docker, you can use the same and the same commands. Again, instead of Docker, just write Podman, hello world, and you're going to see the same result. In some containers, for instance, the one that the example it gives is Docker run. I'm going to run Docker run Ubuntu. We're going to see what happens. Let's see. What happened? Let me go up there. Nothing happened. But I can have access to, so it didn't show me anything, but I can have access to that container. How? I can do docker run -it, which means that I want to access this container with an interactive terminal. So docker run -it Ubuntu, and then I have access to the container. And then inside the container, and it's again, I use Linux Mint, that's what I use. But now I'm running a container which has Ubuntu. Yeah, it's the same operating system, but it's a different distribution. Inside, I have access to everything inside that container. So for instance, I can do ls, so I have all the file system here. I can ask who am I, root, and the host name, and it's these numbers and letters here. And this is completely different to what I have in my, So the container is completely isolated. Who am I? This is on my home. I'm Alex. Inside the container, I'm the root. And what is the host name? In my home, it's Alex idea path 5, blah, 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 blah. Inside the container is completely different. And inside the container, I can do many things. So I can go to home, and here I'm going to run Python. I don't know if it has Python installed this container. No. So, but we can install Python. Let me see, sorry, just let me see. As you can see, I can have access to a complete file system for Ubuntu. And, okay. Oh, sorry, I lost again my, sorry that I keep changing the size of the but for some reason I lose my. Okay, so I'm going to install Python. So this is apt get inside the container install. Let's see if it works like that. Doesn't work. I'm going to try with another one. Okay. Yeah, I'm gonna, no. Let's see if it works. Thanks. And then let's see if it works. No. No. Let me do it in a different way. Well, I know it works. To leave the container, I just type exit and I leave the container. I'm gonna run a different one, which is Alpine, which is another distribution, and it's lighter. There is another good practice here. Again, with this command, I run a container from an image. But then the thing is that every time that you run a container, you're going to save that container is going to be somewhere. So it's a good practice to include this --rm, which means that when you exit the container, it's going to remove that container if you don't want to keep those containers around. Of course, if you want to keep them, don't put --rm because it's not going to keep that container there. So we're going to run again Alpine, and we're going to do the same. As I said, okay, let's see if Python is installed. No, but I can install it here. I think it's easier. I hope so. Okay. Again, it was working yesterday.
There is no Python.
No. Oh, yeah, but okay, let me. Thanks. Then I have Python 3 installed in my container. So I can modify what I can install packages in my container, and I can do whatever I want to do here, right? So, yes.
I have a question. What if you change your mind? So you run the container with this .rm, and then you don't want to remove it when you exit. Can you do this from inside?
Well, actually, let's see what happens if I exit this container and enter the container again, and what happens. So, in a minute. So here, where I have Python, I can also add, for instance, if you use R, you can install R as well. And then let's see what happens if I exit this container. Well, for this case, I remove this container, so it's not going to be around anymore. This is the, okay, the list of containers, but let me see if let me see. Yeah. Okay, again. I enter the container again, but then Python is not installed. So you have to be careful again when you leave the containers, and if you want to remove that container or not. Okay, so it's not Python here anymore. So probably you will have to install it again. There is another way. This is what we have done here is to pull an image from Docker Hub. But if we want to have control over that, we want to write our own Dockerfile. In our own Dockerfile, we can install Python from the beginning, and we don't have to install anything inside the container. But we're going to see that in a moment. So let me leave this container, and let's see. For instance, you could also run Docker pull, and you can pull this Python 3.9 dash slim, and well, you have here two options. Even if you haven't pulled the image, you can run the image, and if you haven't done that before, it's going to pull and run the image. So let's do that, and then it's done there. I think I did that before, so that's why I don't see anything. But Python, and then can then I can run it, and then what this container does is to enter directly to Python, so I can use it directly. So it's Python 3.9, and this slim, if you're gonna find this constantly, this slim means that it's the basic Python that you can run on your system. Okay. As I show you, we can run images. We can run containers from an image, and we have different options. We can run Docker run and the name of the image, or if we want to have access to the shell bash, then we have to include the -it. Or if we want to remove the container after we exit the container, we can include the -rm. And also we can have all the list of containers, so we can do Docker PS or even Podman PS, and you don't see anything. But there is a way to see you don't see anything because there is not any container running, but you can see all the containers that you have run in the past. So you can do Docker container ls -- all, and then you see the complete list here. which include the information. This is for Docker, the container ID, the image, the command to access that container, when it was created, status, when it was used before, and ports, for instance, if you see in particular for the Peak Coffee project that I showed you at the beginning, since we use this port to see the plot on a web browser, So all these are the containers that I have run for a while, and also if you run Podman container ls all, you see again all the containers from Podman that I have run, and when, as you see here, the status when it was run. And actually I have some of them that I didn't remove, I didn't close for some reason. Okay. But we also want to remove images. So let's say, and again, the reason why I want to do that is because although the sizes of most of them are not that, they are very small, 300, 152 megabytes, but sometimes you can find very large images. You want to remove them. So, for instance, I want to remove this image, Alex-P-Coffee, which was probably a previous version. Docker image. And it says that it's not able to remove that image. And the reason is that there is still a container which is being used. And actually, this is the container. This is if you remember here, this is the image ID. But here there is some information, the container ID. So that number with letters there is the container ID. So to remove an image, I have to first remove the container if it is still used. So in this case, what I have to do is to, actually I have it here as well. So it's Docker remove, and then we add this the container ID, done, and then I can remove, I can do again Docker image remove and try it again, but this still another container. So I open apparently many. So Docker remove, done. Again, I can do Docker image remove. There is another one. Let's see if, okay, no, that was the container. There is another one, apparently I have a lot of containers open, so I have to remove all these containers before I can remove the image. So you can see all the containers that I was able to run from the same image. Still. Let's see if. Oh. Oh, apparently it's okay. It's already gone. Then let me see the Docker image ls. It's still there. Okay. 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 Apparently, I have a lot of containers. I didn't realize that I run a lot of containers before. So finally, yeah, done. Okay. So I finally was able to remove that image. I had like 6 or 7 containers used, still using that image. So again, I have to, if I want to remove an image, and if I can't do that, it's because there are still containers running. So I have to remove those containers first, and then go and remove the image. So if I do docker image images, then okay, so Alex/pcoffee is not there anymore, so that's good. I want to keep this one because at the end I want to show you again. And if you remember, that image was like 1.5 gigabytes. So I remember recently I erased one of about 17 gigabytes. I don't know why it was that big, but I had to remove that. Okay. Any questions, comments? Yes.
I don't really understand if there is a link with Pixie. With Pixie, do we put a Pixie file into Docker, or we don't need, or what are the relation between both?
Between Docker and Podman? Oh, what do you mean? I'm sorry.
With Pixie, Docker and Pixie, it's complementary, or
it's Pixie is a package manager. It's completely different. It's a package manager. A container goes to the operating system level. So you can have a complete operating system running. Well, you can do that with you cannot do that with Pixie.
But we can put Pixie inside the Docker, or it's useless? We can?
This is what I show you. At the end, I'm going to show you that again with a little more time. But the pcoffee project that I showed you at the beginning, Pixie, I installed in the Dockerfile. You can include that. I want to install Pixie. I did that, and that's probably that's why it's so heavy, this one. But Pixie is already installed in the container. And I'm going to show you that in a moment when you run a Dockerfile. Actually, you use an image base, which is basically the operating system. And there, you can install whatever you want to install. In this case, you install Pixie inside the operating system in the container.
If I if I pin my package versions inside the Docker and test it for, test it and then share it with someone, does Pixie become optional to install inside Docker, or does Pixie have any?
Well, you can do, actually, when I was doing this, I did that in 2 different ways. And you have to be careful when you define the Docker file, because you can install Pixie from the beginning. And you have to deal with anything else once you are in the container. You don't have to install anything. You just run Pixie. And for some reason, when I was building the image, it was installing every time Pixie, and it was taking a lot of time. So the solution was to install Pixie explicitly in the Dockerfile, and it ran well. But again, that depends on what you want to do. I would say there are different ways to write your own Dockerfile. I found a way. Probably it's not the best one because it's not that small. They have to find the best way to do that. I included in the Dockerfile, and it works well. And actually, it's much better to do that from the Dockerfile, I think. Yep, that's.
I think the question was more like, if you pin yourself all the dependencies of the project, can we remove Pixie and use Docker? I think the answer could be yes, but that means that you will have to do that yourself to pin all the dependencies, which Pixie does for you. So in a sense, yes, you can do that, but it's really extra work that Pixie does automatically. So. Yes, all the, for example, NumPy, exact version, Matplotlib exact version. But
you have to be careful.
The Pixie lock does that for you, so you should still use Pixie, I think, inside the Docker.
Yeah, and can add also that some companies are more reluctant to play with Docker due to the fact that they are running on the root level. So at least in my company, they don't allow me to play with. So maybe Podman would be an alternative, but so in that case, I am on the path to Pixie.
Well, you can use Podman as well. I mean, yeah, because Docker, as I said, has this problem, and it's for security reasons. It's not.
That's also why often Singularity is used, no, for this root issue.
Yeah. That's why Podman, Podman is better. For instance, even to install is easier. Just apt-get install Podman, and that's it on Linux, right? And you don't have those problems like in Docker with all this, the root and the daemon playing around. Or even Apptainer, I think, is also good.
Okay, another question, I think you.
The main difference between Podman and Docker is if you use it as a client, it's quite the same because, as you see, all the options are identical. So Podman just run as a client, and Docker can run as a client, but Docker is do much more things, because if you run a container, you can say it's a service on your system. So when you restart your, maybe for example, if you want a database, if you use Podman, you run the database, but if you restart your computer, the database will not restart automatically. But with Docker, there is something in the system that say, okay, I can run at start of the computer, I can manage all the container. That's why it needs to be to have root access, because it interacts with the system directly. If you want to do that with Podman, you have to use other tools. Then the goal of the tools will be to start the Podman container at startup. So it depends. If you just want to run, for example, Jupyter Hub, you can run Jupyter Hub with Docker or Podman. But if you want to start a database or a service or a web server, you can do that with Docker. It's very simple. But if you want to do that with Podman, you have to add some configuration in your system. So it depends on what you want to do. And then the difference between Podman and Docker and Apptainer. Podman and Docker are the goal of Podman and Docker is to run an application. For example, you can run Jupyter Hub. Okay, it's not create to, for example, to connect on the container and to install things. It's not the good way to use Docker, because you Docker container just run and give you an application. It's a application view for container. And if you want an environment, maybe as for UV, we are installing environment, but if you use Conda, Mamba, or things like that, and you want to have a Python environment and work with it, it's better to use Apptainer, because Apptainer don't run an application. It just give you an environment in which you can connect. And Apptainer, you just have to do a curl Apptainer and install Apptainer. It's there is no link with the system. But Docker or Podman, even with Podman, if you are on the computer and there is no Podman, if you want to install Podman, you have to ask to the admin to install Podman. But Apptainer, you don't have to. But Apptainer, with Apptainer, you don't run an application. You create an environment, and you can work on. And with Docker and Podman, you run an application.
Yeah, it's. I'm gonna show you that later. That with Apptainer, as I show you, the Docker, the current Podman containers are completely isolated from the file system of the host. But with Apptainer, you can have access to everything at the same time. So that's really, that's really nice, because you can interact with your own file system. And
that's why Apptainer is a containerization solution in HPC environment, because it's very similar than Conda, Mamba, but in containerized environment. And sorry. And with Docker, you can also run Docker, and without beroot. There is when Podman start to grow, Docker has created a rootless version of Docker. So there is some equivalent to Podman with Docker.
yeah, Docker Docker has a lot of tools now. Actually, I think they develop these Windows containers as well. So that's. Any other questions? Well, we have. Okay, let me. Okay, that's good. We pulled images before, but we pulled those images from somewhere, right? As I said before, Docker has a public registry, which is this Docker hub, in which you find all these images, and even if you use Podman, well, you can. We're gonna see later what happens with Apptainer, which is a little bit different, but it works as well. But with Podman, it's the same. There are other hubs, but Docker hub probably is the biggest one, and you can find anything here. So, for instance, if you look for Python, then you have all these images here. Okay, more than 300,000 results for Python, but we're gonna go to the first one. You also have to be careful. For instance, this is a Docker official image. Again, I can create an account here, and I don't need an account to pull images, but I need an account to push images. And but of course, you have to be careful, because again, with as we said before, these security issues, you have to be careful about the source of the image that you are pulling. There are official images like this one. It's Python, and you can see here Python has different tags here. So these are the different versions for Python, and and you can choose anyone here, and then you have here the command to pull that image. And if you see here, there are again different tags, and if you go to one of these, it takes you to the GitHub repo, and this is the Dockerfile for that image. So you can have access to not only to that image, you can pull that image directly, but you can see the Dockerfile for that image. And of course, these are very long, big Docker files. I'm going to see that later today. But these are very good examples. So you can see from, this is the image base that they are using, in particular for this version. All the information that you can find here, again, these are all the tags, all the different versions that they have, the quick reference, what is Python, and here how to use this image. And this is really nice because it says how to create a Docker file for your application, for your project, using this is the basic information that you can find in a Docker file, or if you use Python 3, or even if you use Python 2, and how to run those images, or how to run the container. Well, first, how to build that image from those Docker files, and then how to run those the containers from those images, and the license. Also, if I don't know, for instance, if you use R as well, you can use here to the R base. I did something. Okay. This is for R, again, all the versions that you have and how to pull those versions. And again, the Docker file, which created that, will build that particular image, and what is R, and how to run, actually for this, in this case, how to launch R directly for interactive work, and well, again, how to use it in a Docker file, how to build it. So it's really nice to find all this information here. And again, just be careful with the source of the image, because let's say in general, there is a rule, as you can see, the image, it comes with something like this. It's the name convention for the Docker images. You have the owner and the name of the container image, semicolon, and a tag. And the tag basically gives us information about the version of that image, as we saw, for instance, here for Python. Let me go back. So for Python, you can see here, this is Python semicolon 3.15. So Python is the name of the container image, and everything after the semicolon is the tag, which is again the version of that version for that image. And you have here more information. And again, if you have an account, well, for that account, basically you're going to have to include here this owner is the name of that account, which again, it's a useful one, especially if you want to push container images in Docker Hub. Okay, so that's the source of those images. But again, as I said before, what if what we have done so far is to pull images from Docker Hub, right? And as I show you, those images are built from a Dockerfile. And this Dockerfile has all the information that we want to be included in the image to be able to be run in a container. So we can create our own image. We can build our own image. In order to do that, we have to write our own Dockerfile. Let's see. Okay. So we have to write our own Dockerfile. And why would we be interested in creating our own image? There are many reasons. The first one is customization. So probably there is not a container image with all the tools that you need to run your application or whatever you're doing. Reproducibility is that it helps you to archive specific versions of your project. As I said at the beginning, one of the advantages using containers is that it also works as a documentation, because it helps us to archive specific versions of a project, the state of a specific version. And collaboration, because it share a unified workflow. So for instance, for the peak of a project, with the container, we make sure that everyone is using the same, exactly the same workflow. And well, we already went through the installation, interactive installation. As I show you, we can install in a container using Docker or Podman. We can install different packages if we want to use something. But okay. So a Dockerfile is a text document that contains all the commands that a user could call on the command line to build an image. So basically a Dockerfile, well, it has many layers, but let's say the basic ones are these three ones. I'm going to run a basic one in a moment. So for instance, from existing image, we start from an image base. I'm going to show that in a moment. Then in run, we basically put there the commands that we put in a shell. And CMD is the commands that are going to be run in the container by default. So if you remember, let me see if I have it here. Let me see if yeah, for instance, this one, when we run this one, it goes directly to Python. So the CMD, the command, basically, well, you know now that the command in the Dockerfile should be something related to Python, because it runs Python once we run the container from that image. Okay, so let me let me show this one. There are some best practices. Okay. So there is, we have this link where we have these build best practices. I think, okay, I think included the ones to build. Oh, okay, yeah. Okay, so in this part, there are some Dockerfile instructions. This is from Docker docs. These are some recommendations to follow to use the Dockerfile. As it says to create an efficient and maintainable Dockerfile. So you say, for instance, here it says from is the image base, and it says that whenever possible, these current official images as the basis for your images. Docker recommends the Alpine image, as it is tightly controlled and small in size, is currently under 6 megabytes, while still being a full Linux distribution. Also for label, for run, split long or complex run statements on multiple lines separated with backslashes to make your Dockerfile more readable, understandable, and maintainable. You can run chain commands, apt-get. So you can have all these, you can apply all these best practices in order to improve the way how you write down your Dockerfile and also the size of the image at the end. And okay, so I think we can go to the coffee break, and after that I can show you the Dockerfile and how we can build an image from a Docker, a simple, very simple Dockerfile to run Python, like well, something similar to this one, but writing our own Dockerfile and building the image from that Dockerfile. So I think we can go to the coffee break.